Okay, so now we're going to get into some of the more serious stuff, or the graphing stuff. And before we move on to graphing this and studying the maximal domain range, I just want to talk about a much simpler graph. Let's say 2 to the x. So, talk about the domain and what you need to know about the domain. I'm going to find something to balance, to keep my... This should stabilize my camera there. Okay, domain, remember? Domain is x. Okay? So I'm going to ask you, what can x equal? Can x be negative? Can x be positive? 0? Can x be positive? These are kind of all the values you need to know for domain. For the basic graph. But that's important to know. So now if you think about it, can x be 0? Yeah, 2 to the 0 equals 1. Can x be positive? Yeah, 2 to the 1 equals 2. Can x be negative? 2 to the minus 1 equals a half. This is everything. Minus, 0, and positive. Domain is all real numbers. You think about that. X can be anything. Now look at y. Okay. Range. Can y be 0? Can 2 to the power of anything equal 0? No. Because you think about it here, you get 2 to the 0 is 1. 2 to the 1 is 2. If we keep going up, 2 to the 2 equals 4. 2 to the 3 equals 8. We're just going to keep getting bigger. And if we keep going more negative, it just becomes 2 to the 3 equals 1 on... Everything will be 1 on 2 to the a, or 2 to the a. And that will never equal 0. And this will never equal 0. But the interesting thing is this gets bigger. It gets closer and closer to 0. Like 1 on 8 is close to 0. 1 on 16, 1 on 10 billion is almost 0. Not almost 0, but it becomes closer and closer to 0. So this will be our asymptote later. I'm going to talk about that in a second. But it can't be 0, and none of these are negative. So the range of y is r plus or y is greater than 0. Okay, so that's the basics, and you need to understand that before we go on to this. Okay, so now that we know that, let's talk about the domain. I look at this, I know this number up there can be anything, because it can be positive, it can be 0, it can be negative. Therefore 3x can be anything. Therefore x is all real numbers. So the domain is real, all real numbers. How do I write that? Yeah. Okay, now the range. Well, first of all, I know that this thing, whatever this exponential, is always greater than 0. Okay? And it's always, but it's going to approach 0. So if it's always just greater than 0, and then we subtract 4 from it, what is it? Y will be just greater than minus 4, or greater than minus 4. Okay? Okay. Now that we've done all that, let's draw our graph. Okay, so a lot of you know this is the asymptote, fair enough. I'm going to say why it's asymptote, because this will keep getting closer and closer to 0, but it will never reach there. So if this is closer and closer to 0, it will get closer and closer to minus 4, but it will never reach there. That's an asymptote. So let's go minus 4. So that's y equals minus 4. Okay, now, before we draw our graph, we need to know where x is. Or if it hits here or if it hits here, because we could draw it either way. So we need to know the x value. I mean the y value when x equals 0. So I'm just going to draw my little table. When x is 0, that's 2 to the power of 0. 1 minus 4, y is minus 3. When y is 0, where can I solve it? I'm just going to solve it up here. 0 equals 2 to the 3x minus 4. 4 equals 2 to the 3x. What to the power of 2 gives us 4. No, 2 to the power of what gives us 4? 2 to the power of 2 gives us 4. Therefore 3x equals 2. X equals 2/3. And just for good measure, I'm going to put what value this is when x equals 1. X equals 1, we get 2 to the power of 3, which is 8. Yep, minus 4 gives us 4. Okay? So I'm expecting us to go through here. Expecting us to go through 2/3, so maybe about here. And at 1, it's supposed to be about 4. So it's about here. And like I have difficulty drawing sometimes. So I like to turn it on its side. It makes it easier to draw. There's our exponential. Put this point in, 2/3 minus 3. And you can, just for understanding, just to get an idea of scale, you can put that in. But that's pretty much it. Like, so really, I just want to say again quickly how you do it without all this extra explanation. This is greater than 0, but it's approaching 0. Okay, so -4 with the asymptote. Now, this 3, where does the -3 come from? First, we need to find what value y is when x equals 0. So we need to find the intersects. So x equals 0 gives us y equals -3 from this equation. Y equals 0 gives us x equals 2/3. And we just put those points in. And actually, we're done then. But I just wanted to have this other point just to get a better idea of where to put my graph. And just to show you, you can actually put in any value you like and get out a different y to draw your graph. Okay, we'll be going on to getting equations from graphs next. Okay, sweet.